Hey guys, we're going to learn about limiting excess reactants today with particle diagrams. Particle diagrams are the pictures that you're looking at right now, and particle diagrams are exactly what it sounds like. They are diagrams or visual representations that show the particles that are taking place in the chemical reaction. Remember, particles can be atoms, compounds, molecules, and more, and we will see all of those represented in these practice problems coming up. Now, before we get started, let's take a moment and talk about what a limiting reactant is and what an excess reactant is. A limiting reactant is the reactant in your chemical reaction that limits how much of the product can be made. And the reason why it's limiting how much of the product can be made is because it is going to run out first. So your limiting reactant will always be the reactant that is used up completely, or in other words, is fully reacted. It's going to be the one that we run out of, and that is going to mean that the other reactant will have some left over. And so the name that we give to the reactant that does not fully react and therefore has some remaining after the chemical reaction has taken place is called the excess reactant. And so we're going to look at the particle diagrams and we're going to start to identify what is the limiting reactant and what is the excess reactant. So in number 1, it says the diagram below shows a left circle that represents gaseous carbon and sulfur before they react. And the diagram on the right represents the compound that results when these atoms combine. So in other words, our reactants are carbon and sulfur atoms, whereas our product is this carbon that is bonded to 2 sulfur atoms. Now you'll notice that on top of the product that we also have some carbon that seems to be left over from the reactant side. And these carbon atoms have not become products. Remember, because this is the product right here. So if they haven't become products, what are they? Well, they're the excess reactant. They're the reactant that had been left over after the chemical reaction was completed. So now let's jump down to 1A, and we're going to write the balanced chemical equation for the chemical reaction shown above. So just like we identified in the left side, we have carbon atoms and sulfur atoms bonding together to make a product, which is carbon bonded to 2 sulfur atoms. Now, we will need to balance this because currently it is not balanced. If you notice, we have 1 carbon and 1 sulfur on the reactant side. However, we have 1 carbon and 2 sulfurs on the product side. Now, we are not going to look at the number of reactants and products, number of reactants and number of products, in order to guide us in how we balance. We are simply going to look at our chemical equation here, and we're going to balance it here. And the reason why we're going to make sure we're only looking here to balance is because we want the simplest ratio of reactants to products. We don't want to look at what we have in our beakers. If you think of this as being, the beaker with the reactants in it before they reacted, and here is the beaker with the products in it after the reaction is taking place. We don't want to look up here because the amount of reactants that we happen to pour into the beaker to react together does not dictate the simplest whole number ratio that we need in this equation. Okay, so we're just going to look at this equation to balance it. And this seems to be a pretty easy equation to balance because we simply need to make sure that we have 2 sulfurs on the reactant side. And now we have the same number and type of atoms on both sides of our equation. Now the next thing that I suggest you do is we're going to go up to our beaker with the reactants prior to reacting, and we're going to circle the ratio. We have a 1:2 ratio. 1 carbon for every 2 sulfurs gives us carbon disulfide. Okay, so I'm going to do that. I'll grab a blue pen. So 1 carbon for every 2 sulfurs. Looks like I can do that again. 1 carbon for every 2 sulfurs. Now, because of my balanced chemical equation down here, I know that when I have 1 carbon and 2 sulfurs bonding together, I get 1 carbon disulfide molecule. So what that means is this group of 3 atoms gave me this product, and this group of 3 atoms gave me this. But again, we are noticing that there's some leftover carbons here. For instance, notice that 1, 2, 3, 4 carbons did not react to make a product. And look, here they are still. 1, 2, 3, 4 carbons that did not react. So because we had leftover carbons that were not reacted, I'm going to write that that is the reactant that was in excess carbon. Okay. Now, which reactant limited the reaction, aka which reactant was completely used up and then made the reaction stop because there was none of it left over? Well, that would be sulfur here. And we're done. Okay, let's move on to another practice problem. I'm going to skip practice problem number 2 because that's one that I think you'll be able to easily answer on your own. There's no particle diagram for it. So let's jump to practice problem number 3. All right, so practice problem number 3 says, the diagram below represents the chemical reaction between nitrogen gas and hydrogen gas. And it is even given us the balanced chemical reaction already. That was very nice of them. So we don't have to write the chemical equation, it has been done for us. And if we take a look at that, it says that for every 1 mole of nitrogen, we would need 3 moles of hydrogen, and then we would be producing 2 moles of NH3, which you can call nitrogen trihydride, or more commonly it's called ammonia. So again, we're saying there's a 1:3 ratio, and if we have 1 mole of nitrogen and 3 moles of hydrogen, we're going to be producing 2 moles of ammonia. And that ratio, the 1:3 yielding 2 moles, is what we need to use when we are determining what is going to be produced. Okay, and that's what this question is asking. It's a little different from the last one, because in the last one, we were already shown the products and the excess reactants. Here, they've given us the reaction, and we need to determine what is going to be in our product box. Now, to make this a little bit easier to understand, I'm going to go ahead and color code everything. So it looks like with the key here, the small atom is hydrogen, and the large atom is nitrogen. So I'm going to make the small atom, so the hydrogen atom's red. And I'm going to make the large atom, the nitrogen atom, blue. So we've got some diatomic molecules here. Okay. Now, just like we did with the last particle diagram, I'm going to ask you guys to circle the ratio of reactants. We said for 1 mole of nitrogen, we'll need 3 moles of hydrogen. So I'll go ahead and do that. 1 mole of nitrogen and 3 moles of hydrogen. And then those together will give me 2 moles of NH3. So I'm going to go ahead and draw that. NH3 means that we're going to have 1 nitrogen and 3 hydrogens. There's 1 mole of ammonia. But remember, there's 2 moles. So again, if we have 1 mole of nitrogen and 3 moles of hydrogen, we get to make 2 moles of ammonia. Well, here is my 1 mole of nitrogen and my 3 moles of hydrogen. So I get to make not just 1 of these, but 2. So I'll make another one. Okay, now the thing is that we're forgetting here, though, is that we had some leftover hydrogen that never reacted. And these 2 moles of hydrogen never reacted because we ran out of nitrogen. So what that means is I need to take into account that there was 2 moles of hydrogen that would still be left over in the beaker after the reaction is completed. So I'll draw those in. There's 1, and there's 2. So let's answer the questions then. So question 3A says, what is the limiting reactant in this chemical reaction? Well, the reactant that limited how many products I could make and the reactant that ran out first is nitrogen. N2. And the excess reactant, the reactant that had some remaining afterwards, is going to be H2. And again, I know that they are the excess reactants because they did not end up reacting. They didn't form any of the new products. They were just remaining after the chemical reaction took place. I hope that this has helped you. Please try the next particle diagrams on your own. From now on, you'll see that the examples are just like the 2 I showed you, where you will either have to write the balanced chemical reaction using the pictures provided of the reactants and the products, like in example number 1, or you'll see an example like we just did here in number 3, where they've given you the equation and you have to draw in how many products are created and if there's any excess reactants that went unreacted.